And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be taking a look at this. This is an Alinco UHF amplifier I bought from eBay. Right, well, this is a small linear UHF amplifier. It's designed for the 70cm ham radio band, and it's an ELH-730A. I would imagine it's probably 80s. I bought it untested, which we all know what that means, but no, this is generally, this came from a silent key sale. And I've got an upcoming UHF project that I'll be doing, and I need a little bit more output power. So for 3 watts in, this will give me 30 watts out. And I've got about 2.8 watts in, I think. I haven't tested that yet. So that'll give me sort of 28 watts. And I sort of wanted 20, so 28 is ample. So yeah, that's what this is. It operates from a 12 volt supply. The pins are 13.8 volts, so motor vehicle charging. STB, which is standby and ground. It's also got automatic switching in it. But I just want to give it a quick overhaul because yeah, we don't want it breaking down. A couple of SO239 sockets, far from ideal for 70cm, far from ideal for anything really, but there we are. That's to the antenna, and this is to the transmitter. It is switched. It's got some RF sensing in it, so when you're not transmitting into it, it turns into a small receive preamp, which will be useful. So yeah, first things first is to get the thing apart. Looking at that, I think the front panel is going to have to come off, and the back panel, I don't know whether this is a clamshell. I think it probably is, because there's a warning, broken seal with void all warranty sticker on here that is indeed broken, but that might just be through wear rather than anything else. So let's get it in bits. Yeah, oh, very short screw. Let's see what, 5 or 6 millimeters long. Coarse thread. It's going straight into that aluminium housing by the look of it. Same again. Okay, right. So front panel PCB, and you'll notice here this switch is broken and it sort of rotates quite happily. Can get it to operate, but I think we need to be changing that. It's also bent. I suspect it's had a wallop. That's not going to bother me too much. Right, yeah, back panel off maybe? No, I don't think so. Ah, there we go. So yeah, we've got a fast slow switch on the bottom here, and this refers to the transmit receive relay that's in there, that will either work fairly fast or not so fast. I think in my application I'm actually going to want it set to fast. Right, let's just take that switch off. We need to note which way it goes round. Oh, tiny, tiny little screws, by the way. Microscopic. Yeah. Okay. I'm just going to get in there with a Sharpie and mark up the one end. I can take it off, so I shall mark this end, and I shall mark the case as well as the switch, look. Otherwise I might select slow when I want fast, or slow and fast words when I want slow, or vice versa. So right, that has removed the switch. It's a fairly standard sort of 70s, 80s fare in here. We've got 2 transistors there. I don't know whether one looks like it's been replaced or not. So I did have a look at the diagram. I managed to find a copy online earlier. And yeah, basically one on the input side from the transmitter takes it up to about 14 watts, and then the other one takes it up to our 30 watts, but it is linear, which is nice. In here is our RF switching relay, and we've got capacitors, and I know what you're saying, oh, don't change them if they don't need to be changed, but that one's shrunk, by the way, straight away, and yeah, generally unpleasant, so we're going to want to take those out. These transistors, by the way, will be bolted to the heatsink, so we'll be renewing the thermal doodah on those. We seem to have plenty of screws holding this thing together. Yeah. Need to make sure that none of those are sort of tuning a cavity or anything. I mean, the thing is lump tuned, and at UHF you'd sort of expect that. So we've got an inductor here. We've almost got an inductor there, look. That's sort of one turn. So we want to avoid disturbing those as much as possible. And these are RF chokes, I would think. That's probably from the power rail, just to choke off any RF getting back into the supply. So let's take that one out. Okay, that's come loose. That's come loose. What do we got? 15mm, looks M3 to me. So we can get this one out. I suspect they'll all be of the same or similar length. Yeah. Okay, got some more around the first transistor there. Or is it the second? I don't know. We'll go and have a look on the diagram and stick it on the screen in a second. These are ever so simple, these things. There ain't much to them. People get scared of RF amplifiers, but there really isn't much to worry about. This transistor here, I suspect might... I don't know what that's doing actually. That might be the transmit switch, maybe. It's connected to the front panel. Maybe it's keeping an eye on the bias. Right, let's liberate that. Just to note, oh, slightly shorter screw. Slightly shorter screw there. There is a mica washer behind that. Right, RF transistors. I'm going to get a proper screwdriver in there. Because otherwise I'm going to clobber the corner of that inductor, and I really don't want to disturb that if I can help it. Okay. Very short screw. M3. It's interesting. Have a little zoom in. I mean, you can see that on camera, but the brand name of these resistors is Honda. Let's leave you about there. Right, shout if you can see any more screws. This PCB over here, you can just see hasn't got so much ground plane. That's your transmit receive switching, and I think the receive preamplifier. So I'm going to need to disconnect the coax from the input and the output. So let's just get the iron on and do that. You're going to need a bigger tip to do the grounds. Okay. Ooh, smell of the 70s in here, must be said. I can't see any date codes, I understand, so yeah. Right, what am I going to do with this power plug? I think I'm actually going to see if I can push it back through the chassis. Yeah, that's going to work nicely. Avoids disconnecting anything. Right, I think, oh no, I need to disconnect those grounds. Right, let me switch tips. Put my big chunky tip in there. Super. Right, moment of truth. Let's see if we can lift this out. You often see amplifiers advertised on eBay and AliExpress. Right, there is a final screw underneath there, look. Right, I'm just going to take note of where that inductor is and just try and move it out of the way gently. Didn't want to do that really, but needs must. Make myself a mental note to move that back. Right. Okay, that's it, we're away. Yeah, as you can see, that thermal grease there, oh, it's got a little bit of stick left to it, but not much. All wants renewing. Yeah, as I was saying, you'll see these advertised on eBay and AliExpress and places like that as pallet amplifiers, except for a pallet amplifier is generally just the transmit side. Sometimes they have relays on, sometimes not. We've got some unpleasant looking joints there. The main thing I want to do really is change out these ancient capacitors. They've certainly done their time, and yeah, I need this thing to be quite reliable, I'd like, so no point in risking it for the sake of a few pence worth of parts. Right, let's get into that. Right, so first thing I want to do is just note the polarity of these capacitors. I'm just going to mark them on the board because there are no markings on the board whatsoever. And in fact, some of these capacitors don't even appear to have two sets of through holes. So we've got minus there, minus there, minus on this side here. This one seems to be a bit of a diagonal kind of angle, as does this one. Minus is on this side, that one minus on that side, minus on that side there. Okay, so the first thing I want to do is I'll do these two little ones on this side here. Like I say, they've only got one pin through the board, which means the other pin is on the trace side itself, which is not going to make it extremely easy to do. I think I'm going to put the desoldering gun on. Right, that's my desoldering gun warmed up. Let's see if we can't get this out. Yeah. The problem we've got is it's actually soldered both sides of the board. So this is going to be a little bit tricky really. So we can't heat it up enough to pop it out. Yeah, tricky. Gotcha. Right. Thankfully, reassembly should be a little bit easier. Now we need to find out where the negative leg goes, and sorry, the positive leg goes, and yeah, it's onto this land here. So let's move that wire out of the way a bit. Here under there, and finally we've got it removed. So it is, and it stinks of rotten nastiness. Oh yeah, it's been leaking. Good job we're in here then. 47 mic, 16 volts. I suggest we've probably got two of these, so what do we got? 47 at 25. Ooh, dropped him. Yeah, it's 47 at 25, so that'll be perfect. Let's get the one that exited stage left. There he is. And I'm just going to sort of copy where that lead went. So we were over there, and we're a few millimeters long. That's going to be the one to try and solder up first, really. Yeah, I don't think my hole is clear. No, it's not. Could be a job for some desoldering braid, which is here. That's cleared it nicely. The other thing I'm just going to do is just tin the lead that doesn't go through the hole, that sort of goes flat onto that pad. I'm going to turn the lights down because we're getting a little bit of glare on that PCB, aren't we? You can't really see what's going on. So yeah, let me widen the angle a shade as well. There we go. Some solder. There we go. So let's just pop that through the hole. And we can see where our leg goes into that pad there. Really? There we go. And solder that leg in. Lovely. Right, that's one of many. On to the next one, which is that pad there. We should just, let's put a bit of fresh solder on there. That'll always aid matters. Problem with these boards are they've got, you know, large copper areas and ground planes, etc. It's just very difficult to get the heat to transfer. Yeah, but the hole still hasn't cleared out. This is challenging, to say the least. I think I'm going to be constantly swapping tips here. Yeah, let's try the hole clearing tool, see if that will push the solder through. Just the thermal mass is what's giving me the problem here. I think we have success. We do. Excellent. Right, same MO. We need to bend the leg out into the approximate location, cut him short. Just tin it up. I'm going to try and use this big tip even down in that little hole, because yeah, it's just difficult. Finally, and that, actually looking at the way the schematic's wired, I think that is the bias transistor, which maintains the amplifier in a sort of linear mode, because both transistors are supplied. Oh no, that's red. Where does red come from? But that's, yeah, that transistor is connected in line with that. So I suspect that's what's going on. I might be wrong. Right, that's those two done, and it's taken ages so far. Right, I'll go at something a little more conventional. Over here in the preamp, we've got none of that big, wide tracks with ground on. It's just a simple through-hole component here. So we should be able to manage this one without much in the way of trouble. Famous last words. This is 22 microfarads at 16 volts. Now even this is going to be problematic. Get both pins on there and see if I can just pull it free of the board. Right, that's one side gone, the positive side. And the negative side. That capacitor looks alright. 22 mic, 16 volts. Just clean that one hole out there. Oh, which is going to be easier said than done. It's not even a double-sided one. There we go. Right, 1, 2, 3 done, 3 to go, and these are going to be really awkward. And for that reason, and the fact that it's getting quite late at night, I'm going to stop there and come back to this shortly. Right, well, it's been a week or more since I've been in the workshop, because I've been working away. So we got these 3 capacitors changed, at least one of which was leaky, so we just got to do these 3 now. So these look even worse than the others to get out, so this is going to be fun and games. Right. Just see the level of heat you've got to put in there just to get the solder to want to move. And you can see, let's zoom in so you can have a look. Too far. There we go. You can just see that joint there. Let me point. And you can see it hasn't sucked the solder out from the other side, and that's because the other side is just a solid mass of copper, which is a problem. So we've just got to keep throwing heat at it until it yields. I'm also running out of room to sort of turn the capacitor, because I'm trying to pull it out of the board and I'm running out of room on the other side. So I just wonder if I can get in this side and undo our positive leg. Oh, it's desperately awkward. Yeah. If I get in like that under that inductor. I'm not worried about moving. That's got it straight away. Yes. I'm not worried about moving that inductor too much because it's a choke and it just keeps the RF off the power supply as the transistors gulp current. So just, yeah. It's not keen on coming out. There it goes. I felt it move. Come on. The last little bit of the way. Come on. Yeah. I have to say, it's a Rubicon part and there's absolutely no sign of leakage. But we'll have a new one anyway. It's 100 microfarads at 25 volts. That's it. 3 new ones. These are 63 volt rated, but March technology and all that, they're about the same size as the old one. So that's going to make our life a bit easier. So once again, bend the positive leg over. Snip that off to about the same length. I'm going to tin that up. We've got to clean that hole out. Oh, have I cleared a hole? I have. Fabulous. Right, let's place our new part in the right position. Make sure we get that good and hot so the solder can flow down onto the other side of the board. Right, and just repeat for the other two. at last our 3 capacitors are replaced, 6 in total. So yeah, not an easy or pleasant task, but there we are. We have you know, strived and come through the other side. Next thing I need to deal with is this bent and broken on-off switch. Right, I've got a drawer of possible candidates for replacement of the switch. First thing I need to do is just undo that nut. I want to avoid scratching that front panel if I can. Let's see if we've got a suitable nut key that'll do the job. Not sure I'm going to. It's quite a small one. Oh, what's that looking like? Yes, just the job. Come on, there we are. Right, it's allowed us to get the front panel off. Okay, so let's just have a look at that. So off is in the down position. I don't mean to do anything about that anyway, that's how switches work. So right, I shall recycle those nuts and washers. On the back we've got the 2 power wires. Oh, that just broke off. Where did that break off from? Must be that connection there. Right. Okay. That's the PTT transmit light. So right, let's just take that off of there. Take that off of there. Let's warm up the desoldering gun to get that off, that switch off there. I don't think this is double-sided. No, it isn't, so we can get away with that. While that's warming up, I'm going to strip that black wire back. So we've got something to solder back onto. Oh, come on. There we are. Let's put something over that so you can actually adjust the exposure a bit and see the bit we're working on. There we are. That board is so reflective. Okay, guns ready. There's our defective switch. So, made in Japan, 6 amps allegedly. We must remember not to switch it when it's transmitting, because I don't suppose these will be 6 amps at all. Although that's looking nice. What's that? .48 volts. 4 watts max. Oh, it's a little bit bigger. But all that means is there'll be some thread sticking out the front. Let's see what these are rated for. How many years of my life have I wasted opening Ziploc bags? There we go. Same looking thing. 6 amps. Oh, it's the same part. We got an extra leg because this is double throw, but that doesn't matter because it doesn't matter because it'll do nothing on the front panel. Right, we're going to need a blob of blue tack there just to hold that down and straight while I solder it. There we go. To be honest, to give it a bit of mechanical strength, we might as well solder that bottom one up as well, if it will. I don't believe it. Is this? Oh no. There we go. Yep, that's working. Right, so we want a back washer. There we go. So we want to get that positioned like that. That goes on like that. Leads into that front washer there, which goes over like that. I think I need to lower that down a little bit more. Excellent. That looks brilliant now. So we need to attach a bit of wiring back on the back of here. Perfect. Right, one last job before testing, see if there are any other faults, is to just clean this old thermal paste off and yeah, renew that. There we are. Right, so let's get some fresh thermal compound in there, which is up here somewhere. There we go. Oh, spare memory card or something. First things first, we do need to get the paste off the old transistors. There's almost none left on that one. There we go. Right, bolt everything back together then, really. So I'm going to put some compound on the heatsink side of it. There we go. Far too much as usual. Place our mica washer. Need to clean that heatsink, the compound off the back of that transistor also. It's in position. We need to just put a little bit on there. Okay, that's more than enough. As usual, the internet will be on fire telling me now I've put too much on, but hey. Get it somewhere near lined back up. Drop those transistors in place. We are good. First thing to do is to get those transistors bolted down. I've just started that screw. I'm just going to leave them loose and then work around them all at the end. Just move that inductor gently back into position. We've got the one last screw to do on this transistor here. Then we can start bolting all the rest of it down. The screw for this transistor is very slightly longer than the one for the main RF transistors. Thought I was going to struggle with that one for a minute, but it's all good. Right, that's now back together. So, getting closer to testing. Okay, we need to put the chassis screws back in, of which there are many. go. Right, I'm gonna have a cup of tea. Right, cup of tea duly thrown down my jumper. Suboptimal, but there we are. Right, so we've got to reconnect these RF connections here, so I'm just going to fold that out of the way. I need a pair of tweezers. Where are my tweezers? That's ideal. I can just get in there and solder that back on there. There we go. Right, power plug back in. Excellent. Tuck this lot back in here so we can get the top back on. We need to reconnect the switch to the top, and I marked that so I don't get it around the wrong way. Which way is which? That side's got the pen mark on it. Goes back in that way round. Let's pop, get these little screws going. There's a little note there on the which way around this connector goes. 13.8 volts, which is our red lead, so that's correct. That can go back in there. Get the end cap on. Oh, take our blue tack back out. There, long last. It's coming together. Excellent. So 6 capacitors and a new switch, and we should be good to go. Right, let's set up for testing. Right, I have gathered a selection of inappropriate test gear. Excuse the wire, this is where the amplifier is plugged into the power supply. I have an ICOM IC705 transceiver that is connected to the input of our amplifier. The output of our amplifier goes through a dozen blasted adapters into this SW1 power meter. Output from the power meter goes into this very large 250 watt dummy load, which will be ample. Right, so first things first, I've got my power supply connected, so the amplifier is off, so it's just passing the signal through at the moment. One thing, this meter is only calibrated to 150 megahertz. I'm up at nearly 440. These power readings are going to be wrong, but I just want to show a gain, so that's the important bit. Right, let's just key the transmitter and look to see what we're just passing straight through to the meter and the load. This is Golf 7 Golf Quebec Alpha testing. Okay, so that's indicating we're on the 15 watt range. It's about 1.5 watts. Golf 7 Golf Quebec Alpha testing. Okay, so let's switch the amplifier on. I notice our power LED isn't working, but yeah, let's go into transmit, see what power output we get. So I'm expecting 30 watts here, so I'm going to go, well, probably about 15 watts, but I'm going to switch to the 150 watt range. Golf 7 Golf Quebec Alpha testing, and according to that meter, that is what, 100 watts. That meter is not calibrated. Have we got a red transmission light? We do. Golf 7 Golf Quebec Alpha testing. So yeah, we're showing a gain, and that's all I'm interested in. When I incorporate this amplifier into the project in which it's going to be doing, I will try and find my UHF meter, and we'll actually have a look at the output power it's doing. But yeah, I'm pronouncing that a success. Golf 7, Golf Quebec Alpha testing. Oh, actually, I've just noticed something. My power supply is current limiting. Okay, well, that's suboptimal. So let's just, it's probably make more power than it's doing now. Let's put 2 supplies in parallel. That one in there, and that one in there. Right, now we should get a bit, we might even get more indicated power. I mean, the indicated power is rubbish anyway, but Golf 7, Golf Quebec Alpha. No, still current limiting. Let's try again. Whoa. So this is now the 1.5 kilowatt range. Golf 7, Golf Quebec Alpha testing. And that's showing us, what, 200 watts. It's rubbish. It's not 200 watts at all. Or I'd be very surprised if it is. But yeah, that's excellent news. That's working, at least working. So fabulous. There you have it. Frustrating refurbishment of this Alinco ELH-730G UHF power amplifier. That's going to get built into another project now, so stay tuned for that one. But for now, click like, subscribe, do all that rubbish, tell your mates, buy me a coffee and the link down below, and I'll see you very soon here on Doz's Television Workshop. Cheers now, bye.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust, they play nostalgic tunes. Solder smoke and the faint aroma of time in each repair. An art that's so prime. Where wires twist and spark, fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit woes, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. In Doz's shop, with a touch of love, your picture's clear and true. In Doz's hands, pixels flicker back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise as an angle. He bends the light through the lens, creating onyx nights. Oscillators creating sonic waves, bringing back the charm of retro days. Capacitors and resistors in Doz's touch, there's no misfire. Transistors dance to the rhythm of repair. Through the glow, feels like magic fills the air. Voltage pulses, the tune's melodic run. A symphony of sparks, where the work is never done. In Doz's